This is the Q960 sequential controller. It's a voltage source, modeled very closely and almost identical in function to the Moog 960. If you look on the desktop of the EM Lab iMac, you'll see Chris Frank there with probably around half a dozen of them, and can use them for a lot more than just sequencing pitches. Let's talk about the sections. Oscillator section. Frequency vernier, frequency range, coarse and fine. For Lab 6, I suggest you start at 4 and 4 for both, but move the frequency vernier around. You'll hear different effects. Oscillator on button, or if you send a gate in, is what it sounds like. Oscillator off, I don't use, because stage 9 does the same thing, but better. Control input, if you put a voltage in there, it sums with the internal voltage from the frequency vernier to change the speed the sequencer is playing at. If you run this at the audio rates, you can tune it and play it as a digital oscillator. If that seems confusing and someone asks me, I'll explain it. The oscillator output sends out a gate with a 90% duty cycle, so any stage that's active for however long that stage is on, 90% of that time, that oscillator output will be high at 5 volts, and that's obviously only if the internal oscillator is running. This is a row, this is a stage. So this is a 8-stage, 3-row sequencer, and I will refer to the controls by saying or writing something like S1, R1, which is stage 1, row 1, or S6, R3, which would be that one. For the rows, the knobs are continuously variable control voltage that they send. The two outputs are in parallel. They send the exact same signal. You can use either one or both. The range switch goes from 0 to 2 volts at times 1, which is why that's what's printed on the panel. Times 2 is 0 to 4, and then times 4 is 0 to 8 volts. Most folks use the first two settings for pitch, and then the last one for control voltage purposes. The thing with the voltage range setting is that the smaller the range, the easier it is to dial in individual notes, especially when the thing is playing. So if you're modulating those knobs in real time, the times 1 or 0 to 2 volt range, much easier to find your pitch. Stages. The mode switch, one click to the left, it will skip that stage. Straight up is normal, like it's not there. One click to the right, obviously it stops. One additional click to the right, an unmarked setting on the panel, it's a modification that I bought for our units, puts it into reset. The first time you try it, you'll understand what that does, and you'll also understand why it makes no sense at all to put either stage 1 or 2 into reset, even though you can. I will often say or write call a stage. That means push the set button. It manually calls or loads that stage. So if I want to stop the sequencer, I call stage 9 by pressing the set button. Each stage has a gate in or out, exactly what it sounds like. Very powerful, very cool, especially when you have 2 of these. Third row control of timing. If you turn that on, what it does is takes all of the voltage settings for the row 3 knobs, which are still coming out, the output jacks. It also internally normals them into the control input to merge with the frequency vernier. So in other words, you can set different knob settings and it will play different speeds between each stage. That can be very interesting, particularly when you take the actual outputs of any of the 3 rows and run that into a slew limiter so the voltages glide smoothly and they're changing in time between each step. Shift input is something you'll use a lot. Every time you ping that with a trigger or a gate, the sequencer advances, whether the internal clock is running or not. I almost never use the internal oscillator. I just shift them externally because I have a bunch of different sequencers in a master clock, and we have that here in the lab as well, which you'll see. Finally, stage 9. Thank you, Bob Moog. We have sequencers that don't have this, and boy, it's really nice. This is a place for the sequencer to come to rest to. You can ping it with the gate in, or manually call the stage, and what that means is that it comes to rest on a stage that A is sending out 0 volts, so all of this, your oscillators will be oscillating at your base pitch, and B, more importantly, when you press start, oscillator on, or you send it the first shift gate, it starts on stage 1. Very convenient. Keep the stage 9 mode switch in skip. That just means that it will cycle. If you put it into stop, it will play once and then stop on stage 8. You can use that as an elaborate function generator, envelope generator, modulation source. With every time you press a key, it will go through all 8 stages, possibly with different times. So there's an overview of the 960. Very cool module.